Difference, we are going to see creation of a binary tree. Of course, a simple binary tree which may have duplication. So this program will create a binary tree of n nodes total, wherein NL nodes will be to the left and NR nodes to the right. So if n is 3, which means total, NL is nothing but n divided by 2, which will be the whole number 1. So 1 to the left and n minus NL minus 1, that will be again 3 minus 1, which is 1 to the right. So you will have given one center node and half to the left and another half to the right, adding up to n. So let's see how we are going to build this. Okay, so we have the structure defined for a node, data left, right. Then we have a function that builds, takes the number of nodes required and will build, and a function to print the nodes in whichever traversal order that you want. So this is the main program that reads the number of nodes required, and it is going to call T is of structure type. It is going to build n nodes and return to T, and of course then we can print, etc. Now let's look at this logic, how it is going to work. So if I pass, imagine my n is 0, which means no nodes, then it is going to be nothing but it is going to be purely a null tree. That means it will return nothing. If n is 1, which means no left node, right node, so it will build just one node, which is the central node. If let's say n is 3, you will have a tree of this, build one on the center, one to the left, one to the right. So this is 3 nodes like this. So the logic is n given number of n, NL will be built to the left. Here n is 3, so NL is nothing but, we will see in the program, NL is nothing but n by 2. So that is half of an integer division. And NR to the right will be n minus NL minus 1. So suppose we have 5, then you will have 2 to the left, 2 to the right, and 1. So 2 plus 2, 1, 5 nodes. So total. So that is how the nodes are being built. So this is the initial function that builds the structure. We will go to see how exactly the creation takes place. All right. So I'm going to call the function with number of nodes. Then I have some integer variables which are used for collecting the node value x, and number of nodes to the left, number of nodes to the right. And new node is node type, which is different. So if n is equal to 0, if n is 0, then no node, so it is a null tree, then it will return a null. So new node is null, so this nothing is going to take place here. It will return new node, that means it will become a null tree. This will be the tree. That is, if new node equal to, if n equal to 0. Else, let's imagine n is equal to 3. So this is what happened. So if n equal to 3, n is not equal to 0, when the function is called, NL becomes n by 2, that is NL is 1, like that we saw before. NR will be n, that is 3 minus 1 minus 1. So this NL will be 1, NR will also be 1. Okay. So that means NL nodes to the left, NR nodes to the right. Now we are going to build, what we are going to build is, we are going to build the first node, that is the center node, okay, the first node. So this is the function called first middle node. So it reads, the node that I read first will be built as the root. So I read the value. Let's imagine the value read is 1. So 1 is built. Then, so the new node is made, new node structure. It builds a node with left and right pointers. And new node equal to x. So the value 1 comes to the center, becomes the value of the node. New node left equal to BNL. So this is going to go to the left. So NL, new node left, that means new nodes to the left. It is going to build how many nodes here? Now it is going to build, this function is calling with NL, that means it is going to build, NL is 1, that means it is going to call to build this node with here we will be building one node. Okay. Similarly, now what actually happens is, since left is called, it will build the node. So the function will go back, now comes back to the same, so recursively calling the same function. So it comes back here. Now n is 1 because going to the left, nl. So it is not 0, so comes here. Now nl, nr will become 0 because 1 by 2 integer division. So because only one node, so it will become the root node. So there is no left, no right will be built. It will call, but it will end in this function. So there is no left, 0. nr is also 0. Now it enters a value. Let's imagine I'm going to enter the node here as, that is the 2. Okay. Suppose I'm going to build the node 2 to this left. So that is x is a value that I read, and new node data equal to x, 2 enters. Then again it is going to call its left. Actually it will call its left because this node, it will call the side with the value. Now the value that is read this side, nr is equal to actually 0. Okay, nr is equal to 0, which means actually it will return back, which means since it is a 0 node being built, like here, it is going to return null, which means this pointer will become a null pointer, this. So this pointer is not going to be there. So we are going to remove that pointer. So there is nothing here. So it is null. So this is in my third instance, 1, 2, it will also go to its right because in this instance there is a right nl. So this also is null and there are 0. So this will also return null, which means both will become a null pointer. Both left and right becomes null, which means they need not be there. We remove. So the left is over in the first case. So this node is returned, return new node. This node is returned back. Now we traversed from the left here. Now there is also a right in the first instance. So it goes to the right. And now the n coming in this case, the n coming here again is 1 in the first case, just like this one here. So calling again, nl will become 1 by 2. Similarly in this case 0, nl will be 0, nr will be 0, but it will build this node first. Let's imagine this is a node that we are going to build, the value 3. So using this, the value 3 is, then it will also try to go to its left, but this is null because 0, this also is null, so both are 0. So I remove those two. So this is the node created. So node is over, left is over, right is over, so it will return back and we will get back the tree, finally return the node. So finally when we go back to the main program, the t that comes back is the tree that is created with all this node in this structure. So this is nothing but using the recursive style of creating. So we have created the root, then we go to left, then again apply the left right pattern. So if it is second traversal, it will go to its left, build the node, and if it has got left again, go to the left, build the node. There is right, goes to the right. So in this case 3, what it does, the order of making the node actually is first build this node, then goes to the left, build this node, then third instance go to its left, nothing to do here, go to its right, nothing to do, so it comes back as a null node, then return this node back. Then in the first instance, this was the first, this was the second instance. In the third instance, it will go to its right, build this node, again go to left, go to right, no node, comes back. So we have finally the tree. So I think that should be clear about traversal and making a binary tree. So if you look here, there is a traversal scheme that is used here. Of course, this is what is used is in order traversal. You can build whichever traversal that we have seen before to use for printing the tree. So this is a binary tree where duplication is allowed and how creation is done. Thank you.